I'm going to begin with the so-called advertisement that occurs before page 1 of Griffith's book. I just want to mention a couple of things from this part of the book. First of all, on page XIV, which means 14, he shows a little diagram of 4 realms of mechanics: classical, quantum mechanics, special relativity, and quantum field theory. He says that in everyday life, classical mechanics works just fine. When particles or objects are going too fast, the theory needs to be modified, taking into account special relativity. If you talk about very tiny things, then you're going to need quantum mechanics, and really tiny, really fast things are covered by quantum field theory. The important message is that in this book, apart from the last chapter, we're going to be talking about classical electricity and magnetism. This is a classical theory. Next, on page XVII, which means 17, there is a mention of electric charge. And I would highlight these points. Electric charge comes in 2 varieties. Which are referred to as positive and negative. And they're called positive and negative because their effects tend to cancel each other. Second point, charge is conserved. And he mentions a global form of charge conservation, which means the total charge in the universe doesn't change, and a local form, which is actually also observed in nature. We'll talk about local charge conservation more in the second semester. The final thing I want to mention from the advertisement is the part about units on page XVIII, which means page 18. So let me read a few words from that page. The subject of electrodynamics is plagued by competing systems of units which sometimes render it difficult for physicists to communicate with one another. The problem is far worse than in mechanics, where Neanderthals still speak of pounds and feet. In mechanics, at least all equations look the same, regardless of the units used to measure quantities. Newton's second law remains F equals ma, whether it is feet, pounds, seconds, kilograms, meters, seconds, or whatever. But this is not so in electromagnetism, where Coulomb's law may variously appear as, and he gives 3 different equations, depending on whether you're considering the Gaussian system of units, the SI system, or the Heaviside Lorentz system favored by elementary particle theorists. The Gaussian system is also known as CGS, centimeters, grams, seconds. The SI is the meters, kilograms, seconds that we use in most of our classes at UVU. And this book uses the SI system. Appendix C will tell you about the translation between the different systems of units.